Mobile Solar with AM Solar. This is our second podcast episode. I hope that this one clears up a lot of the audio issues that plagued our first one, but we still aim to provide quality content. I'm Garrett Town. I'm an electrical engineer. I've been designing solar systems and working in the solar industry for about a decade now, and I'm here with Mitchell Boyer. And what are your credentials, Mitch?
Hey there, I'm the system design engineer here with AM Solar. Background, I just was a bicycle mechanic for 10 years, and I've been learning a lot working here for the last 7 years and applied my knowledge well, I guess. And, I've been helping design the systems and inventing stuff and having fun.
Right on. This episode is going to focus on charge controller selection and array design. And specifically, we'll be talking about Victron MPPT charge controllers. Why do we like Victron charge controllers? Because of the quality. They are top notch. They're marine rated. Their programmability is great. It works for basically all battery chemistries. Bluetooth capability, compatibility with other Victron components like system monitors and temperature sensors. And what else can you add on the topic of why we are big fans of Victron charge controllers, Mitch?
Yeah, they're one of the most flexible, or if not the most flexible solar charger that I know of on the market. When it comes to, DC solar charging systems, with their solar charger, you can put up to 250 volts on the PV side. Most of their charge controllers can handle 100 volts or 150 volts depending on the size, but just the massive amount of flexibility. You can parallel panels, or you can series them all the way up to 250 volts if you care to on some of their models. So I think it's just great in what they are capable of doing. And something to mention, they've recently come out with, well, not too recently, they're expanding on the Victron Connect smart network, which allows the solar charger to use information direct from the battery monitor. So I think you were mentioning that earlier, but that really optimizes the behavior of the solar charger and ensures that charger is behaving exactly as the battery desires. So
okay,
really, yeah.
So the first thing I want to talk about with Victron charge controllers is what the different words and numbers in the part name mean. So you've got like a Victron Smart Solar 100 dash or Smart Solar MPPT 100-50 charge controller. So Smart Solar means that it has a built-in Bluetooth module. The other versions are Blue Solar that do not include Bluetooth. And then it's got two numbers. In the example I used, a 100-50. That 100, the first number, is the maximum input voltage. So that's the open circuit array voltage of your solar panel array. And the second number is the maximum output current that the device can feed to a battery bank. What does MPPT mean? That stands for maximum power point tracking. If you were to create a graph that shows how much current you could get from a solar panel, so the x-axis would be voltage, the y-axis would be current, you'd get what's called an IV curve. It's just it starts out kind of as a line that slopes downward, and then it takes a sharp turn and slopes downward at a much faster rate. And at that point, tip of this, where it starts sloping down quickly, that is the point where you're going to draw the most power from the charge controller. It's the combination of voltage and current where you draw the most power, and that's called the maximum power point. This point fluctuates depending on the temperature of the solar panel and the irradiance, or how much sunlight it's getting. So if the solar panel gets cold, that IV curve shifts to the right, meaning that the voltage goes up. So on really cold days, you get higher voltage, which means you could get more power output. The curve shifts upward if it gets brighter. So if you're in an area where it's really cloudy, that curve is going to be low. You're going to get less current. But if it's bright sun and you've got clouds like right next to the sun for that edge effect, you get a IV curve that's a little bit higher. You get more current out of it. So there's MPPT and PWM. PWM is the cheaper version. It stands for pulse width modulation. Our podcast isn't going to talk about that very much because we very rarely deal with that. Pulse width modulation charge controller doesn't pick the most efficient point for the panel to operate. It just manages a direct connection between the solar array and the battery bank and pulses that based on the charge status of the battery. So it's not nearly as efficient. I say, it depends on the temperature and the brightness, but usually an MPPT charge controller will give you about 20% more efficiency or more output than a PWM charge controller. So on to system array design. So there's three basic limitations we need to consider when we're designing a solar array or selecting a charge controller for a solar array. You have the input voltage limit, the output current limit, and incoming current limit. So let's focus on the input voltage limit. Typically, with the arrays that we install, we put all the panels in parallel, and that maximizes the partial shade resiliency of the array. So if one panel's shaded, it's not going to bring down other panels in the solar array. And when you have all your panels connected in parallel, it's usually a voltage of about 25 volts, the open circuit voltage of the array, and that is well under the 100 volt limit, or in some cases with larger charge controllers, it's 150 volt limit. If you had, say, 4 100-watt solar panels and a 100-30 solar charge controller, you wouldn't want to put those 100-watt solar panels all in series, because on a cold day, that would exceed the input voltage limit, because usually those panels have a voltage of about 25 volts open circuit. The next thing we think about is the output current limit, and you can overload Victron charge controllers, and I believe there's a couple other brands like Morningstar and Blue Sky that allow for some slight overloading, but we're going to focus on Victron here. And I came up with a simple formula that helps you figure out what size charge controller you need for the output current rating based on the total wattage of your solar array. So you take the total wattage. Let's say you have 3 200-watt solar panels. That's 600 watts. So 600 watts, you multiply that by 0.9, because you're going to lose 10% roughly due to inefficiency and weather conditions not being perfectly right. So times 0.9, that gives us 540. Then we divide it by the nominal voltage of the battery bank, not the charging voltage of the battery bank. This is just a simple approximation. And so 540 divided by 12, that gives us 45 amps. So any charge controller rated at 45 amps or more is going to be ideal for those 3 200-watt solar panels. And again, this is just a rule of thumb. You could probably put a smaller charge controller on that. You're just going to be wasting potential of the array instead of a nice bell curve throughout the day. During a really bright time during the day, around noon or so, you might have that curve flatten off as the output current is limited by the charge controller. And the way it does that, its energy isn't being lost or dissipated in the form of heat. The charge controller just draws current at a voltage that's slightly less efficient along that IV curve that I talked about. So it's just making the panel operate less efficiently so that the charge controller isn't being overloaded. And then something that people don't think about very often is the incoming current limit. We bump into this a lot with the 100 amp charge controller from Victron, the 150-100. It has a 70 amp input limit. So normally you'd be able to put 8 100-watt solar panels in parallel on that charge controller. But Mitch, how do we get around this situation where you can fit 8 because of the output limit and the voltage, but the incoming current limit would overload it if you had 8 parallel connected panels?
Yeah, so the basically Victron solar chargers, as Garrett was saying, have really 2 input criteria. You have to be below the max current, you have to be below the max voltage, and once you've paralleled more than 8 panels of that size, you're going to be clipping the max current. And so the best way to overcome that is to series parallel the panels. You could series them all into a giant string at high voltage, but typically we like to keep the voltage a little lower for RVs and also for shading reasons. But you basically series parallel them to double the voltage of the panels and cut your current in half to stay below that 70 amp max current on that solar charger. And something that's a little bit challenging when you go looking at solar chargers, trying to pick one out. Even Victron's calculator can be a little overwhelming at times. There's really only two factors that matter when you're picking solar panels and a solar charger. As long as your array, whether it's configured all in parallel or in series parallel or all in series, as long as your array is below that max voltage, that first number in the MPPT number there, and below the max current, which is a little harder to find, you have to go to the data sheet to locate that information, then it will work. And like Garrett said, you can clip kind of the overload the solar charger, in which you're going to be wasting some of that energy. But a system like that would operate really well at a higher latitude. So if you're somewhere up in Alaska, for example, where you've got much lower sun, then you can use a larger solar array per solar charger and optimize the usage of those solar panels.
That's correct. If you had 8 solar panels on a 100 amp charge controller, you would do 4 parallel groups of 2 in series. So you'd be feeding it with about 40 volts, and then the current would be probably more like 40 amps instead of 80 amps if they were all in parallel. And this current rating, we base that on the array short circuit current, not the array maximum power point current. Another thing, like this podcast, it piggybacks off of one of our really popular YouTube videos where we talk about the same topic. And one of the questions that I constantly get is, what if I put my panels in series? Can I get away with a smaller charge controller? No, because what the charge controller does is it transforms the high voltage, low current that comes into it into a lower voltage, high current that leaves it. So it shifts the balance between volts and amps. And there's an equation that volts times amps equals power. So you've got volts times amps equals power coming in, and then you've got that same power minus some inefficiency coming out with just a different balance of volts and amps. And my formula for figuring out the optimal charge controller current limit doesn't take into account whether panels are in series or parallel, because it doesn't matter. It's just total array wattage times 90% divided by the voltage of the battery bank. And that's the charge controller you can use. Another question I got is, or more of a snarky comment I got on the YouTube channel, said, let me bring it up here. Absolutely no consideration for low temperature operation. Running 30 amps into a 30 amp charge controller is setting your customers up for failure. As they are in a cold environment, the temperature will spike in the morning and burn out the charge controller. Well, that's not true. That's not how a Victron charge controller works. You can overload a Victron charge controller, and if you have the potential to generate 40 amps, that's not going to burn up a 30 amp charge controller. The only thing that will damage the charge controller is exceeding the input voltage limit or exceeding the input current limit. And if you are doing this early in the morning on a cold morning, the sun's going to be low, so there's not going to be a lot of current in the first place. So this was basically, I don't think you know how a Victron charge controller works, and it doesn't, temperature is not a big deal. Let's talk about some of the other features of Victron charge controllers. If you have a charge controller that is 70 amps or higher, they have a remote disconnect. So it pairs nicely with a Victron BMS that takes like a 12 volt signal. As soon as that signal drops away, the charge controller will stop working, which is good for batteries with an external BMS, and it's a nice disconnect feature because you don't want to be charging lithium batteries when they're below freezing. So that's a good way to deactivate that. Otherwise, we would put a Victron battery protect between the charge controller and the battery bank and have that activate the same way. Mitch, can you talk about some of the other unique features of Victron charge controllers, maybe CAN bus communication and the implications of that?
Yeah, sure. Something I wanted to touch on real quick that you were talking about earlier. So when people do want to try and optimize their solar charger, like Garrett was saying, you cannot series your panels to reduce the size of your solar charger, but technically you can series your batteries and reduce the size of your solar charger. The higher the voltage of your output, the more solar wattage potential your solar charger has. But the challenge that you have there is that RVs are designed for 12 volts. And so you have to overcome that by having a voltage converter and a system that basically in both charging and discharging is capable of converting from 12 to 24 volts. And beyond 24 volts, things start to get a little bit trickier because 48 volts just really isn't supported in the industry. There's not enough components. So 12 volts is really easy to work with. It's the industry standard. 24 volts is a possibility, and it's something that we install here and support other people installing it, but it still comes with its own set of challenges. And 48 volts, maybe someday. I think that we're not quite there yet. But yeah, to touch on some of the other MPPT solar charger features from Victron, the CAN bus and both VE direct interfaces allow the solar charger to communicate to a central monitoring system. So for Victron, they've got the GX monitors, they've got the color control GX, and they've got the Servo GX with the Touch 50 display and the Touch 70 display now. So you've got these really nice interfaces which can connect to all the different electronic components in the system, solar charger, battery monitor. You can also connect in other devices like tank sensors and volt sensors and temperature sensors within the system and get like kind of a central monitoring system for your RV. They haven't really been integrated from the manufacturer standpoint yet, but I think that that's what Victron's going for. And we'd love to see tank sensors and whatnot get integrated into the displays there. But yeah, so the solar chargers can communicate through a VE Direct connection, which allows basically all the information that's in the solar charger to be shared with that central monitoring system. And the CAN bus also can allow for larger MPPT solar charger systems. It's not something we deal with too much in the RV industry, but you can connect, gosh, I forget how many, but something like 100 solar chargers together via a CAN bus communication system using their RJ45 cables. And that allows you to really expand systems to a very large degree. But yeah, the GX monitors are able to take that data and compile it into some pretty cool graphs and allow you to access that in a lot of different ways. Victron has what's called the VRM portal, and that is something that when you get a GX monitor, if you connect it to the internet, it automatically creates its own account and starts to transmit all of the data that it collects to this account. So you can use like a micro SD card for when you're off grid so that you're not losing that captured data. But every time you connect to the internet, it's going to upload all the solar chargers information and as well as all the other connected components. And what that allows you to do is create graphs of your usage, and you can actually track where your power is coming from. For example, like from the generator, shore power, and solar, and actually figure out where your consumption is really coming from. So it's a pretty cool little feature and really expands on what the solar chargers are able to do.
So what are some situations where somebody might have multiple charge controllers in an RV system, and what kind of wiring or communications would need to be in place for those charge controllers to maybe talk to each other?
Yeah, so the solar chargers, like on a Class A, for example, a larger RV, if you're running a 12-volt battery system, you're only going to be able to run up to 100 amps out of a single solar charger at 12 volts. And so that means you can only put approximately 1,400 watts or so on the roof. You can put more wattage on the roof, but at peak hours, you're not going to be getting all that energy out of the panels. So often it's going to be optimal to put in two solar charge controllers instead of putting one 100 watt solar, or excuse me, 100 amp solar charger. We'll put in like two 70 amp solar chargers or 85 amp solar chargers. And then those can both be connected into the same monitoring system. As it's displayed from the GX monitor, the two solar chargers information is grouped together. But something that beyond the VE Direct connections, you can also do the smart networking, which is pretty cool. So you can connect multiple solar chargers together through a smart network, which allows them to communicate and share information so they can start to work as a team and basically being in the same stage and transition at the same time. And then it can also get a total.
In other words, you don't want one charge controller to be in absorb mode while the other's in float mode. They'll be working against each other.
Yeah, exactly. Also, if one solar charger is set up with a battery bank, if it's got its own set of information, like it's looking for a specific amount of tail current before it finishes, when you have two solar chargers, they can kind of trick each other into thinking that you've reached that tail current sooner than you have, basically kind of skipping over part of the stage, the charging stages. So yeah, grouping them together allows them to not just look at each other's information, but also the battery monitor's information with the smart networking. And so you can have like a smart shunt in the system that's transmitting the current that's going in and out of the batteries. And in that, the solar chargers can know exactly how much of their energy is going to the loads versus to the battery, so they can accurately know when to basically transition from absorption into float. So there's a lot of little benefits that come from the smart networking, and I'm really impressed with the way that Victron's been implementing these technologies.
So when you have a system, do you network them over Bluetooth, or do you run a COM cable between them, or do you just have them go to the central monitoring device like a CCGX or a Servo?
Yeah, that's a good question. So if you're running them to a GX monitor, which I would say is probably the preferred option, you get the most out of the system that way. Then you do not, I don't believe you want to network them at all. The smart networking is something that doesn't really function along with the hardwired networking, because when you connect them both to the GX device via either CAN bus or VE.direct, you're basically going to be networking them automatically through that system. And then the smart network is going to be something that you would use only in systems that don't use the GX device, so that the system can communicate, basically over Bluetooth between the solar chargers and battery monitor.
Okay, speaking of networking, sometimes you will network a charge controller via Bluetooth to a Victron BMB712 or Smart Shunt if you're charging a lead acid battery and you need temperature compensation and you can't have your charge controller in the same bay as your batteries. Normally, Victron charge controllers get their temperature from ambient, but if you have to have your charge controller in a different area just because of limited real estate, you'll network the charge controller to the battery monitor, so your charge controller has an accurate idea what the temperature is on your batteries. Is there anything else we need to talk about in regard to Victron charge controllers? I think I've said about everything I know.
Yeah, that's just about it. We covered most everything. One thing that I think is pretty cool, that this is both for solar chargers and for the standard AC to DC chargers that Victron sells. For example, the IP22. Yeah, with that new smart networking, really what's going on there, just to kind of explain that a little bit more, when you connect a battery monitor to the smart network, the solar charger, let's say you're trying to charge a battery in absorption at 14.2 volts. The solar charger is going to put out 14.2 volts and hope that it gets to the batteries. And if you have a long wire or an undersized wire between the two components, what happens is by the time you push some current through that wire, the voltage is going to drop as it gets to the battery. And the consequence of that is that your solar charger, or any charger for that matter, can think that it's charging at a higher voltage than it actually is. And the more voltage drop you introduce to the system, the less accurate the charger is, and the quicker it's going to skip over charging stages. So by connecting the smart network and allowing the solar charger to see what the battery voltage is as well as the current, it's going to actually know exactly what it's delivering at the battery. And what it does is increase the voltage. So even though we're trying to charge at 14.2 with the battery, the solar charger can increase the voltage to 14.5 or 15 volts if it needs to overcome that voltage drop. And you do lose a little energy through resistance, but you're actually delivering exactly what the battery wants to it and what you've programmed the solar charger to do. So that's a really cool feature that I don't think there's really any other components out there that offer something like that. Victron really stands alone in that. But the way that it increases the voltage to overcome loads is really pretty awesome. We're really excited. Or overcome voltage drop is a really great add-on to the system.
Well, that's the end of our podcast. I hope this was informative, and we look forward to doing some more. Thank you.
Thanks for joining us.